Alright, so let's dive into DC circuits and learn how resistors and currents work together in electric circuits. Whether you're troubleshooting a flashlight or building complex electrical systems, understanding the dynamics of DC circuits is fundamental. Today we'll cover key principles like voltage, resistance, current, and resistor combinations. We'll also work through practical examples to solidify these concepts. Ready? Let's get started. Understanding the basics. A DC circuit allows current to flow in one direction through a closed loop. The simplest circuit consists of three components: a voltage source, such as a battery, wires to connect everything, and a resistor, like a light bulb. When a battery is connected, it creates a potential difference, or voltage, across its terminals. This voltage drives the current, which is the flow of electric charge through the circuit. Electrons move from the negative terminal of the battery to the positive terminal. However, by convention, we describe current flow as moving from positive to negative. This is called conventional current flow. Using Ohm's law, we calculate current using the formula. Current equals voltage divided by resistance. Example 1. Let's say a battery provides 1.5 volts and a bulb has a resistance of 150 ohms. The current would be current equals 1.5 volts divided by 150 ohms, which equals 0.01 amperes, or 10 milliamperes. This shows the small current that powers devices like flashlights. Resistor configurations. Resistors in circuits can be combined in two primary ways: series and parallel. Understanding how these configurations affect current, voltage, and resistance is crucial. In a series configuration, resistors are connected end to end. The total resistance is the sum of individual resistances. For example, if three resistors have values of 5 ohms, 10 ohms, and 15 ohms, the total resistance is 30 ohms. The current is the same through all resistors in series, but the voltage drops vary depending on each resistor's value. In a parallel configuration, resistors provide multiple paths for current. The total resistance is calculated using the reciprocal formula. For example, if two resistors, 6 ohms and 12 ohms, are in parallel, the total resistance is 4 ohms. In a parallel setup, the voltage is the same across all resistors, but the current splits between them. Mixed circuits. Many circuits combine series and parallel resistors. To analyze these, simplify the circuit step by step. Reduce series and parallel combinations into single equivalent resistors until the circuit is fully simplified. Example 2, here's a mixed circuit. Two 10 ohm resistors are in parallel. Their equivalent resistance is 5 ohms. This 5 ohm resistor is in series with a 20 ohm resistor. The total resistance is 25 ohms. Using a 12 volt battery, the current is 12 volts divided by 25 ohms, which equals 0.48 amperes. Power in circuits. When current flows through a resistor, it dissipates energy as heat. The power dissipated by a resistor is calculated using the formula. Power equals current squared times resistance. Example 3. A 5 ohm resistor carries a current of 2 amperes. The power dissipated is 2 squared times 5, which equals 20 watts. This heat dissipation explains why resistors sometimes get warm. To find the energy dissipated over time, use the formula. Energy equals power times time. For the same resistor running for 10 seconds, the energy dissipated is 20 watts times 10 seconds, which equals 200 joules. Practical applications. Resistors have countless applications. Voltage dividers are used to create specific voltage levels in circuits. Current limiting protects sensitive components like LEDs. And heat dissipation is essential in power systems to manage energy safely. Example 4. A 100 ohm resistor is connected to a 9 volt battery. What's the power dissipated? Power equals voltage squared divided by resistance. 9 squared divided by 100 equals 0.81 watts. This small power output is typical for everyday devices like remote controls. Advanced circuit concepts. Let's analyze a more complex circuit with multiple branches and voltage sources. Use step-by-step reduction to find the equivalent resistance and solve for current and voltage in each branch. Practice challenge. A circuit contains 3 resistors, 10 ohms, 20 ohms, and 30 ohms. The 10 ohm and 20 ohm resistors are in parallel, and the combination is in series with the 30 ohm resistor. First, find the equivalent resistance. The parallel combination is approximately 6.67 ohms. Adding the 30 ohm resistor in series gives a total resistance of 36.67 ohms. Next, calculate the current using a 12 volt battery. The current is 12 volts divided by 36.67 ohms, which equals approximately 0.33 amperes. And that's a wrap on DC circuits and resistor combinations. Understanding these principles will empower you to tackle electrical challenges with confidence. For deeper insights and practice, visit kotc.me. Until next time, keep learning and stay curious.